All right, welcome back.
Hey, developers. All right. Did you get your coffee?
Yeah.
Yeah,
We're good.
we're good. We're wired.
Right, so...
But we're also wireless.
Oh, there we go. A seamless link to the next session.
Yes.
You're good. You're
yeah,
really good.
I'm trying.
Yeah.
I'm trying.
So this network session is about networking. So
I love
we're going to talk about networking. Yeah. Now, you know, it can be a bit of a dry subject. You're just moving stuff from one place to another. But
it's not dry.
These Windows Phone devices are like so full of different networking capabilities. In fact, the next session after this is about NFC and Bluetooth as well.
Have you seen the network capabilities of this new device here? Is this a iMate? Yeah. I don't know. HTC. You're going to love this. The networking, it's got a joystick on it.
Ah,
it's a paperweight. No, this is great stuff. You wouldn't believe what's on this phone.
Yeah.
I'm excited about networking. I think it's arguably the most important thing.
Well, indeed. There's a lot of stuff to cover, so let's get straight into it.
Yes.
Network, there's a nice network drawing.
Look at that icon.
Isn't that great?
Wow.
So this is what we're going to talk about, networking for Windows Phone. There are a couple of APIs, web client, HTTP web requests, which you use for kind of low-level, raw HTTP requests across the network. We're going to mention briefly sockets, so we haven't got a lot of time to dig into that, unfortunately. But then we're going to spend quite a bit of time on web services and OData, because there's a lot of interesting developments in that area. Simulation dashboard. Now, data compression, very important for making a good quality network connection, just to make sure that you're using compression on the wire. Phones run on crappy networks most of the time. You have to assume that they're going to be. So anything you can do to minimize the amount of data traffic you require, the number of bytes you require to transmit in order to get the data across is a good
Unless
thing.
you're in Korea.
Really?
They've got a great network everywhere.
Yeah.
Saturated.
Yeah. Now, not included on that list, because I have added it at the last minute and forgot to add it to the agenda, is we're going to have a quick introduction to Azure Mobile Services, which is a new thing that came out. There was good coverage of that at the recent Build conference. So
excellent.
We're going to take a very quick look at how that works, because there's some pretty exciting stuff happening with that as well. Okay, so that's where we're at. Networking on Windows Phone. So first of all, introduction, what we have got in terms of support for networking features. Good support for WCFs, accessing WCF services in all their different flavors. RESTful and SOAP and all the rest of it. HTTP web request and web client are the low-level APIs. Sockets, as I mentioned. We've got full HTTP header access on requests. That's something we didn't have when Windows Phone first came out. We have no restrictions like that. And we have full support for NTLM Kerberos authentication in Windows Phone 8. So there we go. So,
a dream come true.
Yeah.
Realized.
Really. So this is another feature that's adding up to the value add for our enterprise applications. So intranet. We've now got good, strong authentication there. So
Kerberos.
Indeed. So the new features in Windows Phone 8. In summary, what we've now got two different sockets APIs. So System.net, which is what we've been using forever in Windows Phone 7.1, is obviously all still there, but that has been upgraded with new features, notably listener sockets. But we've got the Windows RT API as well. Windows.networking.sockets is in there, so that's an alternative. So if you're doing cross-platform between Windows Phone 8 and Windows 8, you can share a lot of your code there. Support for IP version 6. So a lot of this kind of stuff comes from the benefits of having the shared core with Windows 8.
Right.
Because a lot of the support for things like IPv6 is kind of at the low level of the OS. So these are some of these shared modules that we're taking advantage of at a low level of the OS.
We're happy to ride on the coattails of big Windows.
Yeah, that's right. So that's a good benefit of IPv6.
Let's get all the stuff we can get for free.
Yeah.
Yeah.
And we've got listeners, or NTLM and Kerberos, I mentioned that. We've got incoming listener sockets. So with sockets, before, if you wanted to do a sockets connection from one Windows Phone 7 device to another, you basically couldn't.
Right.
You had to kind of go via an intermediary, sort of sitting on a server or something. So that sucked.
Right.
Now we've actually got listener sockets, so you can open a socket and wait for an incoming connection.
Feels peer-to-peer-like to me.
Yeah, indeed.
Yeah.
And we've got WinSock support for C++ dev. So that's been added in. We mentioned this yesterday. It's kind of primarily there. It's not there because we kind of think, oh, you're going to go out and start writing all your stuff using WinSock. But it's there for helping you to port existing code libraries that you may have.
Right.
So this is a quick summary of those networking APIs and a comparison of what we have on the Windows Phone 7, Windows Phone 8, and Windows 8 platforms. So the two main APIs for programming that we've used on Windows Phone 7 are Web Client and HTTP Web Request. Now, Windows 8 has a flavor of HTTP Web Request, but it has been rewritten to just use this async await task-based methods. We don't have those async await task-based methods in Windows Phone 8, but I'm going to show you in a few slides' time how we can work around that, and you can actually use make awaitable calls to using HTTP Web Request. So we've got a kind of a workaround for that. Instead, the web client is the brain-dead easy API to use, and we've still got that on Windows Phone 8.
Which is great for people like me.
Yeah, absolutely.
Brain-dead.
Yeah, but it was too complex for Windows 8 devs, so it got removed from there. And instead, they have a whole new one called HTTP Client, which was is in the version of the APIs used on Windows 8, which is totally asynchronous and very efficient. And unfortunately, we don't have that on Windows Phone 8. A couple of other flavors of convenience APIs, if you like, on Windows 8, the Syndication Client and the AtomPub Client are specifically for accessing those kind of feeds. We don't have those. But then when we get down to old school Asimix web services, SOAP-based web services, great support across all the platforms, WCF services and OData services, we've got a good story there.
And remember, when we say WCF services, we really mean things over HTTP. Some people will say, oh, well, you mean you're going to do named pipes or mail slots over the internet?
Right,
Probably
sure.
not so much.
No, that's right.
Yeah.
No, so yeah, we're still talking basic HTTP web request response stuff.
Absolutely.
Which is, when you're working over the internet through mobile operator networks and that sort of thing, that's really what we need to constrain ourselves to.
Named pipes don't do well through routers.
No, not good. No.
Not so much.
No.
Okay. All right.
So that was a quick summary of the APIs. Now then, this thing about async support, async and await, which is the new way of writing asynchronous code. Yeah, and it's great. It's cool stuff. Kind of, if you're new to it, it does take you a little while to get your head around it. It's a new paradigm. Oh my God, I used that word.
Wow.
It's a new programming approach to doing this kind of stuff. In desktop.NET 4.5 and in the Windows 8.NET for Windows Store apps, all of these networking calls, as long with everything else that is a potentially long-running operation, they're all now based on this new task await, async and await model, the task programming library stuff. And we don't have that, unfortunately, in the Windows Phone 8 APIs. So, but we can actually kind of add this with a few little workarounds, and I'm going to show you that in just a moment. But before we do, let's tackle this one head on.
Right away.
Right away.
We're not going to shy away from tough stuff.
No, that's right. So there is something to trip you up. Trip you up if you are working with the emulator, and it's a difference it's quite a substantial difference from the way that the emulator on Windows Phone 7.1 worked. Yep. So we need to look at this. Now, what we've got is the problem is this: with Windows Phone 7.x, the emulator was based on the previous virtual PC virtualization technology. And it wasn't actually, a completely separate client. It was actually using shared networking. It was hosted by your development PC OS, and because it had a shared networking, there was this neat little trick they did that you could access resources that you had created on your own dev PC in Visual Studio just by using a local host URI. Now, actually, what local host means is on the same device where you're running the code. So actually that shouldn't have worked. I mean, it was a convenience for developers, so you could just test your stuff out and it would HTTP localhost from your code running on the Windows Phone 7 emulator, and it would hit your service. And it was great because it was very productive. That doesn't work anymore with Windows Phone 8. The reason being that the new emulator is a virtual machine running under Hyper-V. It's using the newer virtualization technology. It virtualizes right down to the hardware. So it is actually a completely separate host, a completely separate computer on your network. So if you try and access a resource from code running on that emulator using localhost, it won't find it, because localhost means the emulator itself, means the Phone 8 device. And you're not running the web service on that Windows Phone 8 device. So instead of using localhost, you need to just use the host name or the raw IP address in your URIs. So that doesn't sound so complicated, does it?
No, how hard could that be?
Indeed. How hard could that be? Well, that's actually from the client side, that's all you have to do. But there is a complication, again, because most of us, when you're working on networking stuff, you're going to create a little OData service or something in Visual Studio, and you will then expect to, then write your client, you'll add service reference, and you'll run it, and it will fail. And the reason why it will fail is because you've got a lot of configuration you need to do on your Windows 8 box where you're running Visual Studio. So first of all, if you're doing WCF services, you need to ensure that this HTTP activation feature is turned on using in the Turn Windows Features On or Off dialog. So drill down to .NET Framework 4.5 Advanced, go down under there to WCF, and you need to check the HTTP activation there. And then you've got a choice. You're then going to create your website. Now, by default, when you create an OData service, for example, in Visual Studio 2012, that is going to be hosted in IIS Express. So IIS Express is this is a web server that's constrained. It means you don't have to. It's not like full IIS installed on the box, so you don't need to have admin privileges to run it. And it's a very convenient way of testing your ASP.NET MVC apps and this sort of thing. So for pure web developers, it's great, and it just gets hosted in IIS Express. It uses the full IIS code, but it's just a dev version of it. So if you create your service, it will be hosted by default on localhost : some port or other, so localhost : 1809. So there's a little window there showing an ASP.NET MVC4 mobile app that you can create in Visual Studio, and it will have that port number, and it will be on localhost. You still won't be able to access that because by default IIS Express does not accept any connections from remote hosts, and your Windows Phone 8 emulator here is a remote host. So this won't work either. So we have to then reconfigure our website, and it's a slightly contorted sequence of things you have to do. First of all,
kind of like Cirque du Soleil on your device, on your laptop.
It is. It's totally like Cirque du Soleil.
Contorted, yeah.
Yeah. So what you have to do is first of all remove your website from your Visual Studio 2012 solution again. Then, if you go into your My Documents folder, there's a subfolder in there called IIS Express, and drill down to config, and then under there you'll find a file called applicationhost.config. And every time you create a website in Visual Studio, it will put a new entry into this file. It's an XML file. There's a section in there that's sites, and you'll find the new site you've just created in there. And that is where it states, you see that binding line there? It will say binding information equals, and then stuff you see there, asterisk, colon, then the port number, whatever it's assigned to you, and then it will say colon localhost. So you need to go in there, edit that, and actually replace localhost with the real name of your PC, and save the changes. And then you go back into Visual Studio and add existing website, so add that website folder back into your solution again. And even that's not quite enough, you're nearly there. So then you've got to run a couple of command line prompts. So you start a command prompt as administrator. First of all, open the port in the firewall using that command there for the port number. Here we're using an example of 18009. And you also need to add a URL ACL. This is a kind of a reservation that allows you to use that port number for remote requests. So you need to do that second command there, the netshare http add URL ACL. And again, instead of your PC, put the real name of your PC and then the whatever port number. Now, finally, you can just test it with the desktop browser, and we're hosted at, and then you can using the URI of your real PC name, colon, and whatever port. Phew. And then, actually, your code running in the Windows Phone 8 emulator will be able to access it. All good fun.
It is good fun.
Right. So, having told you all of that, we're now going to drill down to the code. So let's do web client first. So this is the simple API, very nice and simple. This is the old school way of doing it, the Windows Phone 7.1 way of using the web client. All you need to do is new one up. Then you hook up an event handler for the download string completed. This is a download string. There's different flavors of different APIs methods on this class. And then at some point in your logic, you'll call the download string async method, passing the URI where the string can be loaded from. And that string could be an XML file, could be some JSON, could be whatever. And when that download is completed, obviously the event handler will fire, and you can get at the text. Right, and I said I was going to show you how you can use async await. So web client on Windows 8 has been replaced by HTTP client, which is purely async based. But we can get web clients to, we can add async behavior to it with some custom extension methods, which allows you to, and these extension methods, and I'll show you them in a minute in a demo, allow you to add download string task async methods to that web client. So you can now use the async await pattern to make calls, which is very much nicer. In fact, I'll show you that demo now. All right, so in Visual Studio, if we can show that on the demo machine, there we go. This has got there's actually two projects in this solution. You can get all this code. We're making that available to you. There's the old school one, which does it the old way with the download string completed, but I'm going to run this one, which is the Twitter Reader web client. This is the canonical HTTP example, and let's just run it first, just to show you that it really works, and then I'll just show you the code. So this is a production from Mr. Rob Miles. This is a couple of what we're going to go off and do is find out what he's been tweeting about, and there we go actually. And the most recent one is actually the report he tweeted about. He posted up about how he just had his little operation. So,
oh wow!
So he hasn't tweeted since then. So I hope you're feeling well, Rob. You know,
broken-hearted.
Yeah. So.
Get better.
He's sadly missed. So yeah, get better. So and then there's his recent tweets. So very, very simple. Obviously, you must have seen a million Twitter readers. But the interesting thing about this sample is just that the code uses the async await. So let's go and find it. Here we go, load button. So there we go. This is the URI to go to Twitter and download the most recent tweets. We're just getting the 10 most recent tweets on there. And here we go await client.download string task async to that. So that will just go off and call us back kind of when it's actually completed and given us the string, and we then parse it using this XElement link to XML and post it up on the screen, which is what we saw there. So we're projecting that to a collection of Twitter post objects. These are extensions though, so just use this, get this code and use it in your own one. This is you need this folder basically, the web client extensions. There's a couple of utility ones. This is the interesting one, web client extensions. This is where we add these extension methods, download string task async. They're extension methods, which means you can use them with the web client class. So use this code and yeah, you've got nice async await with the web client. Right, and next. Now we're going to look at HTTP clients. So if we can go back to the slides on that one. If you want a bit more control, so web client is nice and simple and probably works for most of your HTTP access, but HTTP web request is a bit more complex. It gives you a bit more control. You get right down to the streams. So this is the old way of doing it. You'd new up an HTTP web request. Well, actually, you don't new one up. There's a static method on it called create, which returns you an HTTP web request instance. We can set some HTTP headers, and then you call begin get response, and you have to give it an async callback, a delegate which is going to handle the response when it comes back. And you have to pass, in that begin get response, you must pass the original HTTP web request or a custom object that you've created that includes that HTTP web request instance in it. You need that because you need that to close things off and actually get at the response when the call comes back. And this is what you do in the response. It's all this complicated code. I'm not going to walk through it. You can look at this and use it yourself, and it's well documented. But you can see you get right down to the response stream and pull out the data. And then, of course, you've got a lot of error handling as well, also try-catch stuff around there. So loads and loads of code compared to the web client to kind of actually achieve the same thing. But if web client doesn't work for you, you need a bit more control, then this is the way to go. Now, again, using the TPL pattern, which is the Task Parallel Library, which is the proper name or the originating name for the async await pattern.
Wow.
You start off the same, http web request.create, to give you an HTTP web request instance. Again, we're setting the accept header on that. This is actually going off to an OData service and getting the verbose version of the JSON feed. We're going to look at that in a little bit more shortly. And now this is where this isn't an extension method. This is something you can do with any old school begin end. Any API that offers begin something and then end something. So in this case, it's a begin get response and end get response. So you new up a task factory, and that has a method on it called from async, where you just give it the begin method and the end method, and you can put an optional state object in there as well. And then you can await that task, and you're making awaitable calls to it. And it wraps up all of the complications that we saw before and makes the code much more concise. So this is definitely the way to go. And then once it comes back in, you're pretty much into the same story as before. So you can get the response stream, but with the benefits that exceptions because we're using the async await pattern, you don't have to marshal things back to your originating thread. The exceptions get thrown on the originating thread. The response comes back on the originating thread, and it's a much better way of coding these things. Error handling, like I said, try catch. You don't have to marshal it back. There's no dispatcher.begin invoke, which actually was needed for the previous example. So I've got a sample here on the demo machine. Which is doing just that. This one is calling out to the Northwind service out on the, it's actually out on the web, it's actually on the services.odata.org, so it's on the odata.org site. It's one of their test services you can use. We're setting the application/JSON semicolon OData equals verbose, and then we're using the TPL pattern to make that call to that. And we're going to get back all of the suppliers that are in the Northwind database. And here's where we're awaiting that. So I'm just going to step through that. We're just going to check what content type we've got back. And yes, it sent us back some application/JSON, so we're looking pretty good here. We can read the response into a stream object, get that data out of it, and then I can just show you what it looks like. This is an OData feed. There are lots of JSON, nicely formatted, very pretty. These are all of the, I'm sure this will be very familiar to many of you, the suppliers in the Northwind database. And then I'm using JSON.NET to deserialize them to deserialize that JSON feed. I'm just going to let it run, and we're going to stick the results up on the screen. Got a message box. I'm just interested, we'll come back to this later on in this talk. I'm very interested in the size of the payload here. And there we go, there's all the suppliers dumped onto the screen. So that's a nice example of using HTTP web request, using the TPL pattern, and using JSON.NET to deserialize a JSON feed. JSON feed is much more concise than an RSS XML feed. So this again is a theme about using the most efficient protocol on the wire that you possibly can. So JSON is definitely your friend. If you can use JSON, use it, because it's about the most concise way of transferring data around. Coupled with compression, it's awesome. All right, that was that. Sockets. I haven't got time to go into this, but we have great socket support in Windows Phone 8. So this is low-level networking. So you can make TCP/IP socket connections, which are connection-oriented. So with a TCP connection, you make a connection to a specific port on a specific host, and it's reliable communication. So there's retries and everything, reliability built into the protocol. Or you can use UDP, which is a kind of fire and forget. So it's very efficient, but it's connectionless. So you just fire it out there to a port, and if there happens to be somebody listening on that port, then it will get the data. But there's no reliable, it's not a reliable thing. So you typically use that for sort of on intranets where you've got good quality connections, or gaming that kind of uses that sort of thing. Now, new features in version 8. Windows Phone 8, we've got IP version 6 support, and we've got listener sockets. I mentioned that we can now have a socket connection on a Windows Phone waiting for an incoming connection. And those features, IPv6 and Listener, are built into both the Windows.networking, the .NET API, and the Windows Phone Runtime, Windows.networking.sockets API. And I haven't got time for a sample, unfortunately, so that's just to raise your awareness of what we've got there. Now let's get into something kind of more interesting, web services. So what we saw there, actually, the sample I just showed you, the HTTP web request, we made an HTTP call out to an OData service. An OData service is just another web service, but it's very lightweight. OData services are what we call RESTful services, so you can just use HTTP GETs to pull data down from them. So that's why you can use the low-level APIs. But some of the higher-level web service protocols, things like SOAP-based web services, which we now refer to generically as ASMX services, because we used to use ASP.NET Web Service projects to build these things. We still can, and they had a .asmx extension on them in the URI that you would call. So we've got great support for those still. You can just simply add reference, and it will automatically generate proxy classes. So it generates you some code that sits on the client side and makes it easy to access these objects and pull access methods on them. As Rob mentioned in the introduction, if we can access SOAP-based WCF services, but it is required that you use basic HTTP binding with those. So you can't use the higher levels of binding. So we're a little bit constrained in what we can do there.
No queuing.
No,
over
that's
the internet.
Right. No. Right, I mentioned there RESTful web services. So this is kind of the way things are moving in the industry. The limitation with sort of SOAP-based web services was if you had created a web method, for example, to pull down the suppliers from the Northwind database, you would implement a web method probably called something like getSuppliers. And that was great, and you could add a service reference and you could call it. And if then suddenly somebody decided, oh, we need a new method to get the products that are supplied by each supplier, you then have to go in and create a whole new web method called something like get products for supplier. And then you'd have to refresh your client, and it slows down the whole process. And those kind of web services are not particularly extensible. It's a lot of work every time you want to add new capabilities to it. So RESTful services are more interesting because they, some bright spark at some point realized that all this complexity we're building onto these web services and all this SOAP and all this kind of stuff, and I forget what was the
So a dissertation was written back in like 2000 or 2001 about just using HTTP as it is, the verbs get, put, delete.
Because HTTP has had that since it was first devised.
What is the most scalable system ever devised ever? It's the internet.
Yep.
And it just works. And it's more scalable than anything we've ever tried to invent internally.
Yep.
And so why not just lean on that and just use it instead of trying to build your constructs on top of it, which we spent a lot of time building lots of advanced. There's the WS ** group that built all these type of things you could do with SOAP, which is great if you need it. But REST is, now obviously with REST you don't get a WSDL or something easy to know what you've got to have a kind of an API doc, if you will, that says both ends. If I send you this, you're going to send me this back. So you don't have that built-in contract. But if you're willing to do the extra work, the payoff is it's a infinitely lighter wire protocol that just relies on the built-in constructs of HTTP.
Yep, it's lightweight. And it's the way to go. Now, in terms of our stack, in terms of building services that can expose RESTful data services, the most well-known is OData. So OData is really a nice, flexible way of exposing structured data from a database out, or actually any IEnumerable collection. Actually, it doesn't have to come from a database, out onto a web service. And the feed, the data that you get from it, can be formatted in XML or Atom feed format or JSON. Now, we saw an example of accessing the JSON one there. So you can do raw HTTP calls to it, which is what I just showed you. Or there is this data services client library. So this is sometimes called link to URI. because it allows you to do link queries against objects that are exposed by an OData feed. The data services client is a separate download from NuGet, which you need to do because it's OData is always being revved, so we're up to version 3 now, and you need to get the most recent data services client library to add the add service reference support for Windows Phone 8 projects into your Visual Studio installation. So the latest release, and this literally came out like last week, is WCF Data Services 5.1. You need to download, there is a special installer to update Visual Studio for 5.1. Now what 5.1 is quite a major release. The big feature, and the reason why I'm calling it out in this talk, is that it adds support for the new JSON, what used to be called JSON Lite. I'll explain what, you saw the OData equals verbose format that I was getting before, and I'll explain that the JSON Lite one is a much more concise way of sending the exact same data. I've got a demo coming up that will make that clear. So the OData feed comes with not just the data, but a lot of kind of metadata as well. So it bloats the feed that you're getting from the server. And we like concise. We like it as nice and clean and as thin a data feed as we possibly can, which is what this JSON Lite format gives you. So you need the WCF Data Services 5.1 to enable that. We can generate client proxy to an OData service, and usually add service reference will just work, or you can drop down to the command line utility called data service util _ Windows Phone.exe, which you'll find at that URI after you've installed the WCF Data Services client for Windows Phone. If you run that, you'll spit out a C# file or a VB file, depending on what you've chosen, and you can just add that to your project. And this enables this alternative, not just the raw HTTP request, but the alternative way of accessing an OData service. This is that alternative way of accessing an OData service, and it uses this idea of a you generate when you add service reference, it generates this client-side proxy. So you'll end up with a class such as Northwind Entities in this case, which is a context, a data context, which you use. It's a conduit you use to connect to that OData service. And you get collections of objects from it in these data service collection of T objects. So in order to pull down, for example, the customers, you would new up a data service collection of customer, passing the context into the constructor there, and then you can just do link queries against the context. So the context has properties on it for all of the top-level collections. So for a Northwind database, you'll have customers, suppliers, products. So you can just do link queries against it, and then call the load async method. And this is this link to URI. It actually figures out what the relevant URI is, the HTTP GET it needs to make to go and pull the relevant data down. And then in the load completed, this is where you get your data. There's a little bit of handling you have to put in for a page data feed, so the data can come down in chunks to you, so that logic there will handle that. And then you get your collection of customers, and they're in memory, and you can do whatever you like. In this particular example, we're adding each of the customers we've got to our view model collection, but that's obviously application specific. So this link to URI thing, let's just go back to the demo machine. I'm just going to, this URI is the, I'm going to open this in the browser. Well, I'll do the control click thing, there we go. So here we've got a browser window that is accessing the OData feed. This is, if you see the URI, this is all of the suppliers. This is what it's spitting out in its XML format. So you can see this is all the, which will be familiar to many. The Northwind database was like devised in about, I don't know, 1962 or something.
Something like that.
Yeah.
Before we even came up with SQL.
Yeah, that's right. And the beauty of this is, literally, to build this service is like 5 minutes work.
Right.
And you can navigate the whole database just by changing the URI. So here's the root of the data. So I'm going to remove that suppliers and go down to the root. These are actually the tables in the Northwind database. Categories, customer demographics, customers, employees, order details, orders, products, regions, shippers, and so on and so forth. So if we wanted to look at products, you can just add products onto the URI. There you go, there's all the products. And if we want to get a specific product, well, we could go and say, oh, actually, I only want products 2. So you can put a primary key in there. And now all we've got is products 2. And you get all of this, you see all these link stuff? This is the verbose bit I was talking about. So it gives you everything you need, a lot of metadata that allows you to navigate connections and relationships in the database, which is very convenient. So if you want to find the supplier of products 2, it actually tells you in the feed what you need to do is do an HTTP GET to products 2/supplier. So you can see how it's very, very flexible, and all of this intelligence, and you don't have to create 500,000 web methods in order to be able to get at different parts of data from the database. So it's very, very flexible, and it's a really nice way of doing data feeds. And I will always build my data feeds using OData these days, if I possibly can. If I own the server side and it's data and we need to surface that out to mobile clients, this is the way to go. And it's just XML or JSON, so it works with with clients from different suppliers as well, so not just Microsoft. So that's a quick look at OData. Now then, next, I have been mentioning a few times about network information and efficiency. Efficiency is, we always need efficiency. We don't like mediocrity, and one aspect of mediocrity is inefficient networking. So you need to make decisions based on the state of your data connections. So this is the user experience side of the network awareness thing. So mobile apps shouldn't diminish the user experience by trying to send or receive data in the absence of network connectivity. There's nothing more annoying than hitting a button expecting to see some data and then it just timing out and you get an error. Now, obviously, you can't always, you might lose the connection just when you make that call. So you obviously need to trap that error and give a good user experience. But if you could actually monitor the availability of the network, and if you haven't even got a network, well, then just grey out and make sure that you just put something on the screen saying, sorry, network not available. So you can actually even prevent that frustration if you can. And the other thing you need to do with your mobile apps is be very intelligent about transferring the data. So if you've got, if you've got a large amount of data that you need to download, and they're on a low bandwidth network, they're on a cellular data network, you might want to put a message up saying, connect to Wi-Fi before you download this. So that's, again, being good to your user and giving them a good user experience. We use this network interface type object to get information about the kind of network or the presence or absence of a network, and there are network change events that fire when the network state changes. So if you're being a good citizen, you want to keep an eye on the network interface type. There's also a bunch of other device network information objects. You can get a lot of information about whether you've got a network at the moment, whether we're roaming, whether we've got Wi-Fi turned on, so you can get a lot of information about the current state of connectivity on the device. And we've got some new APIs. The network information is in the Windows Phone Runtime API set called Get Internet Connection Profile, which is really useful for getting the information about what the current internet connection is. So again, you can find out what kind of network we're connected to. And this is a code sample that shows you how you can do that. You can figure out what kind of interface we're on. Are we on Ethernet, or are we on point-to-point, or are we on Wi-Fi? I'm not sure the point-to-point would ever come up. So you can figure out whether you're on a USB pass-through or whether we're on Wi-Fi, which is information that's very useful. Now, not only about monitoring whether you've got a network or not and what kind of network it is, you also need to think a lot about stacking the cards in your favor, about making your networking code work more efficiently and giving yourself a better chance of success. And the best way of getting a good chance of success is about keeping your data volumes as small as possible, using the most compact data serialization available, and using compression. Doesn't actually say that particularly there, but that's kind of allied with that. So if you can, use JSON. If you own both ends of the link, the server side as well, make it JSON. Avoid transferring redundant data. So too often people are lazy, and you've got this data feed, and there's a load of stuff you don't need on the client, but think about putting that little bit of extra effort into just doing a custom feed that's specifically for the needs of your mobile application, so that you're not transferring a load of stuff over the wire that the client doesn't need.
Because the needs of the one sometimes outweigh the needs of the many.
That's right.
Right.
Yes, yeah.
Yeah. So just specific filtered data just for that user. And yeah, efficiency at all level.
Yep.
Efficiency at how we send the data with REST versus SOAP, JSON versus XML, compression versus not. But don't go too far and use a binary format that would block other potential clients, right?
Yeah. So
You know.
yeah. So JSON. That's why we keep banging on about JSON
Yeah,
being
'cause
great.
anything can talk
everybody,
to it.
anything can talk to JSON.
Yeah, absolutely.
Yeah.
Maybe
So-
something like batching too. You have to roll
Yeah.
your own on this, but
Yeah.
if you're
indeed,
going to
yes.
do a query, you're not going to download 10,000 objects in a collection over the wire and hope that it'll succeed.
Yeah.
It might, but it might not if you're on GPRS with
Yeah.
intermittent connectivity.
Sure.
So you might try to batch that up if you can,
Yep. Yep.
which is built into things like sync framework and replication.
Yep.
You would have to do it yourself.
Well, OData services support batching.
Excellent.
So,
Well,
some
then,
batching.
there you
yeah,
go.
So, yeah. So yeah, design your protocol only transfer precisely the data you need and no more. Right, I'm just about to show you a nice demo. Before I do that, there's a question on the queue that I will just handle at this point, which is, the question is, does Windows Phone 8 support a web service endpoint such as WSDL? So WSDLs are SOAP-based services. They publish. This is when you can add when you add a service reference or add reference to your project. Absolutely, it does. So Windows Phone 8 does support that, and you can access them just the same way as you have been doing, hopefully, for the last few years with different client technologies. Right, so this demo now. And let's open the next solution. Just to drill home this point. So this is kind of interesting. I have got, I'm going to close that. I've got a solution here with a data service. An OData service, and then let's just start the client. And it's got 4 buttons on it. And what this is doing is going off to the same OData service, and we're going to get it in we're going to get the supplier's data again from this OData service, and we're going to do it in a number of different wire serialization formats. So just to compare the size of the payload. So the first of them is going off and getting the OData atom feed format. And here I've got a breakpoint set when we get the result back. And so we can actually have a look at the atom feed. So this is, there we go, loads of XML. This is all the suppliers from the OData data, from the Northwind database, along with all of that metadata, all that cross-reference, all those links. Here's a link, for example. So it's it's everything you need, but it's quite verbose. It's actually very verbose. So 28...
Too verbose for GPRS.
It is too verbose for GPRS, absolutely. So there we go. Now, the same feed, you can simply ask for the same feed using JSON, and all you do is set an accept header. This is the verbose format of JSON that we've asked for, and the verbose one, we already saw this in the HTTP web request demo I did, so that's what it looks like. There we go. How big is that? So that one is 15K, so it's a great improvement. So that's the difference in JSON, but you're getting exactly the same data here. You're getting the same information. Now this third one, JSON REST, this is the new JSON Lite format. So the accept header here is just application/JSON. And now what we've got is just the data. So all of those links stuff has gone. So if you don't need the links...
I'm so glad that those links are gone.
Oh, yeah, me too. We've been asking for this, and this has just come out, recently.
Yeah.
There was a CTP that's been around for quite a while, but now this is a full release. It's come out just like a week ago. And the size of that now... Oh, okay, now we're talking 8K.
Wow.
Yeah.
We're
So
getting small.
just remember, this is the same data records, 28K
Right.
8 day. So now we're kind of getting into GPRS kind of territory.
Yeah.
And of course, that's uncompressed though. The last one, the last flavor, is the same thing, the same JSON REST, but actually it's a bit of a fake this, but this is compressed on the server side. It's gzipped. So I've sent the gzipped version of it, and this is the same data, 4K. So there you go.
Wow.
You've just transferred the same data over the wire in 4 different formats, and that speaks volumes, doesn't it?
It does.
So you need JSON Lite, and we need compression.
This goes back to what we've been saying
Yeah.
about empathy for the end user
Yep.
and
totally.
their scenario where they are.
Yep. totally. Yeah, love your user.
Yes.
So that they love you.
That's right.
God, that sounds really cheesy, doesn't it?
It really does.
It's like Rob Miles is here.
The more you know. Yes.
Cheese.
Yes.
Cheese. Yes, more cheese grommets. There we go. So that's obviously a slightly different data set, but it still drills home the point. In fact, I think I got those figures off you, quite possibly.
Actually, well, originally, but I did it without.
Yeah.
I got even smaller because I did some crazy medieval stuff.
Okay.
Like I'll show
Byte
later.
encoding or something.
Well, no, but I got it down
Yeah.
to like 600K or something like that. but you continue to, yeah.
It's the principle. It's getting it as compressed as possible.
OData was different back then than what it is today.
Yeah.
Is a big takeaway, which kind of
Yes.
drove a lot of the things I did.
Yeah.
It was a lot more verbose way back when.
So, how about implementing compression? So, Windows Phone, unfortunately, does not support the system.io.compression.gzip stream method, which is how we would do this on the desktop. So you have to use third-party unzippers in order to unzip a stream that you get from for example, from a web server that has got compression switched on. So there's a couple of popular ones there, SharpZipLib. But there's also a NuGet. You can find that it actually says on Windows Phone OS 7.1. That's actually incorrect. It's now available on OS 7.1 and 8.
Ooh.
So yeah, you can, instead of using web client, if you just get this gzip web client from NuGet, it works exactly the same way. You just drop, you just add the reference from NuGet, change all your calls to where you new up a web client, change it to a new gzip web client. You don't have to change anything else, and that replaces it in place, but adds support for compression. And it does uses this SharpZipLib internally, but it means that on the wire, all your stuff is getting compressed,
That's
which is
great.
really, really cool. Yeah, and it's so easy to use. So actually, yeah, that date, it says NuGet release for Windows Phone 8 not yet available. That is not true, actually. Sorry, that slipped through the slides, because I was working on these demos the last few days, and it is now available. And I missed it in that.
We're now past October.
We are, yeah. There you go. As of October, it says. So
Yeah.
November, yeah, we're good. We've got it. So use it. It's no cost. It's a no-cost upgrade.
You were probably at some Oktoberfest tent somewhere in Munich or something.
Yeah,
when you
that's
did
right,
that.
yeah.
Yeah.
So just a few slides for doing compression. This is how you do with an HTTP web request. You just need to set the accept encoding header to gzip, and then when it comes down, you get that response stream, and you just open you pass that into a gzip input stream, and that will unzip it for you. With an OData client library, you can this is the one where this link to URI kind of method. You can use a technique like this. The reference at the bottom. This is where it came from, the Astoria team. You can add an event handler for the writing request and reading response methods, which allows you to hook into those streams and again use the gzip stream to first of all, the top one is to add that accept-encoding header, and the bottom one is how you would then unzip the response. A very quick little demo which I've got for you for that. Open project solution. Okay, so this little client, I've set up my IIS to compress OData feeds, which is not for the faint-hearted. I will have to blog about that. I certainly haven't got time to cover it, but it took quite a while to set that up. Oh, why is it on the WVGA emulator? That sucks. Sorry, I've accidentally launched another emulator here, which is why it didn't pop up straight away.
I had $1 for every time.
Yeah, no, we've got 4 emulators, and yeah, so I'm waiting for this to...
It's probably a good thing you have a 64-bit version of Windows 8.
It certainly is.
Yes, you might have an out-of-memory exception or
Yeah.
something like that,
Yeah.
otherwise.
Right. Now, this is going to get the suppliers. Now, I'm also going to run up something called a third-party tool, a very useful tool called Fiddler. What? Whatever. Oh no, it's updating. I didn't want that. Anyway, okay, that hasn't taken too long. So now this allows us to look at everything that's going on while we're doing the while we're getting this. So there's 2 flavors of this. At the moment, compression is turned off, so I'm going to load those suppliers, and all the code in there is, we've got 17002, there we go, this is a new version of that demo before. And then I'm going to turn on compression, and all that is going to do is add that accept dash encoding and use the gzip web client instead. And obviously, after it's been unzipped, it's the same payload, the same data. But when we look at the Fiddler output, we can see two things here. This was the first one, which was our there was no compression, and it had 17K on it. And the other one, with compression, we had the gzip encoding, and that was 3998 bytes. And inside that, in the code for this, all you needed to do to enable all of that was, first of all, use compression, use the gzip web client. We're using this as the verbose one. Set the accept encoding. Actually, you don't need to do that because that's done for you by this gzip web client. So that's that's the way to enable compression. And this is the old school way without compression. So that's the only code change you need.
That's great.
It's an easy win. Just go for it.
And so when you got down to that smallest size, was that still with OData when you got down?
Yeah.
With compression?
That was compressed. Yeah, that was a verbose JSON feed.
Because we definitely had a question in there. They didn't know if you just switched to pure REST and JSON with compression, or if you were still doing OData.
Yep, this is still.
And that got you down to 4K.
4K.
Something like
less
that.
than 4K from 17K for it uncompressed down to 4K.
That's great.
Yeah, great. Okay, right, we've still got a few things to run through, so let's quickly go back through the slides.
Run, Forrest.
Go for it. Yes. Very quickly, I'm just going to mention this new DataSense feature, which is a new feature in Windows Phone 8, but it does require network operator support. But you want to think, if you're doing apps that are heavy on networking, you need to sort of think about supporting DataSense. There's a bunch of APIs on there where you can figure out what the network the user is on, and also if they're near their data limit. So the question here is, are we currently using a cellular data network, and are they near their data limit? And then you will modify your behavior. So there's a complicated table here, which I'm not going to kind of walk through, but it gives you the responsible data usage. Basically, if the network cost type comes back as unrestricted, you don't have to. It doesn't matter. Fixed or variable, and there's none of these approaching data limit, over data limit, or roaming properties. Or if they're all false, again, no restrictions. But when it will tell you when approaching data limit you're getting near to the data limit, and then you probably want to cut back on the data you're using, or start putting up messages saying, oh, you need to connect to Wi-Fi for this, or something like that. So it's all about helping your user and making sure that they don't inadvertently exceed their data limit.
So DataSense is a great feature for our end users to help them save money.
Yep.
It really comes down to that.
Yeah. That's right, it is. It's a nice feature.
Yeah.
So Verizon, I think, are supporting it.
Yes,
initially.
I have that on my 8X.
Right.
It's fabulous.
And you get a nice app so you can see your current usage and everything.
Absolutely.
It's really pretty cool. Yeah. Right, briefly, network security. We can use SSL to encrypt data communications with servers that have an SSL server certificate. And for that, on the client, you need to have the root certs for the major CAs, the guys who issue all of the standard web server certificates. And they're all, all the usual suspects are installed onto Windows Phone 8. You can actually install, if you're doing you're generating your own certificates, you're becoming your own CA for an enterprise kind of application. This is not something you'd want to do for a public application. You can install a self-signed cert into the certificate store. It's kind of clumsy. You have to kind of go to a website where it is, or send it on email or something. But then you can install that cert in, and then you can successfully make data calls against an SSL encrypted connection. It's not just about encryption, it's all about authentication as well. So as well as encrypting the data in transit, which is what SSL does, and it authenticates the server, you also need to authenticate the client. So we would use probably basic HTTP authentication quite often over the internet for web services. Key thing about basic HTTP is you pass the username and password over, but that is in clear text. So you must use that in conjunction with SSL so that the data that's sent over the wire is encrypted, so nobody sniffing can actually find out what your username and password is. If you're on intranet, we've now got support for Windows Digest authentication, NTLM and Kerberos.
Wow.
Yeah, great stuff.
So for a client out on the interwebs, they can also now, with the NTLM, even though you're still probably going to need SSL to encrypt it, you can probably now pass in the domain username and password credentials,
Yep.
and have it recognize that when you're hitting your web service or your website, things like that.
Cool stuff.
It is cool stuff.
Yeah.
I'm down with that.
Yeah. Now, how do you add if you're going to pass username and password over, say if you're doing HTTP Basic or one of the other ones, then you need to pass a credentials object with that username and password in it, and then optionally the domain. So you set that on the credentials property. You new up a credentials object and set that to the credentials property of your HTTP web request, and that would go over to that would be sent over with the request. Nice and easy, but clearly, you're not going to want to ask your user to enter those every time you make a call, because that would be kind of annoying.
It would be annoying.
So
I'd probably stop using the app.
You would. So so if you're going to do this kind of thing, you need to have something in the settings, or the first time they run the app, you ask them for their username and password, and then you need to store it securely. And we all know what storing secrets on the client is like bad news. But the good news is we have a class called protected data, which is otherwise known as DPAPI, uses the DP data protection API.
It just rolls off the tongue.
Yeah, that's right. And what it does is it uses what's called a machine key, an encryption key that is owned by and administered by and completely private to the phone, the device. Nobody can ever see it. You never see it. You never see this encryption key. So the protected data allows you to encrypt stuff with a device-specific key. So anybody who intercepts that, there's no way they could decrypt it.
Right.
So this is the way. So the code on the slide shows how to use protected data to encrypt, and basically it's all that stuff is about stream management. But the key line there is the call to protected data.protect.
Heavy use of byte arrays.
Byte arrays are in there, yes.
They're your friend.
And this is the reverse operation where we use protected data.unprotect to reverse it, so you get the clear text bytes out of it. So there's a couple of slides there for you to take away and plug into your own solutions. So you can store that in isolated storage safely and know that nobody will be able to get at that username and password.
Yeah, take this serious. You know, your customers are demanding data at rest be secure, data at transit be secured everywhere.
Yeah. Right, I'm going to wrap up this session just to raise your awareness, really, of a couple of things. First of all, the Live SDK makes it easy to use SkyDrive in your Windows Phone and Windows 8 apps. And there's also an SDK available for iOS and Android. So this is a great way of putting data up in the cloud, so backing stuff up or storing data up there, or work in progress up in the user's SkyDrive. And you can share the data quite easily between Windows 8 and mobile device apps. That's the exciting thing for me. So you can start something on one device or a tablet and then pick up your phone, and because they're sharing data through their SkyDrive, you can complete an operation on the phone or vice versa. So that's where you can get hold of the Live SDK. Windows Azure Mobile Services, I mentioned. You can easily build a cloud backend for your app. It's very easy to create a Windows Azure database accessed via RESTful services. Great sessions at Build on this.
Yes.
Check them out. There are client SDKs for Windows 8, Windows Phone, and iOS and Android coming soon. Really great tutorials on the website. I said I was going to build one. I'm running a little bit over. Let's give it a shot, and it shouldn't take too long.
Yeah, we'll try to keep it under 45 minutes.
45 minutes, yeah. That's right.
Yeah, don't worry about that.
So, stop this. So this is a solution you can download from the Azure the Windows Azure Mobile Services website. This is the solution, the starter solution, which doesn't have any cloud integration in it. Which emulator have I chosen this time?
Hopefully the Azure emulator.
Here we go, that one. The WV. Oh, okay, we're back here. Yes, thank you. So.
Cloud in a box.
That's right.
My
You've got SQL Server installed there, right?
No, Rob.
And you're calling it SQL Express, even if it's the real big one. Because Azure chokes, or you have to change that. Yeah.
So this is my. I've got some to-do items, and I'm saving them, and they just end up as to-do items. But it's just in memory at the moment. So what we're going to do is cloud enable this, so these items get stored up in the cloud. So I'm going to just go off to the browser and start a new tab here and go to, you can see all my recent sites there. catching up with the football. https://manage.windowsazure.com, which is, so I'm going to go and sign into my Windows Azure. You can get a free trial account.
Yep.
Really nice and simply. And I put in my password.
Don't look.
No, you didn't get that. There we go.
All dots, that's easy.
Yeah.
I love the new HTML5
It's nice,
version
isn't it?
of the portal.
It
I
is
think
nice,
it's
yeah.
great.
Yeah. So I can create myself a new mobile service. Here we go. Create. I give it. We call it Jump Start to Do Live. Why not? We're going to use an existing database. So put in the password on that. Tick that, and now it's creating me a Windows Azure database and the RESTful services to access this database.
Outstanding.
Yeah, it's really cool stuff. And once that is created, we should be there. Come on, baby.
About
Come
30,
on.
30 minutes?
Yeah, that's right. Have we got time for this?
Maybe 30
Yeah,
seconds.
no, it's usually pretty quick.
Yeah,
it's
you're
usually
right.
pretty quick. So that's chuntering away. And this is live actually happening in Windows Azure at the moment. It's creating it's created a database.
Ta-da!
There we go. We're cool. So we can go off and create ourselves add a table to it. So now we're creating a table, and this is pretty cute. So I'm going to call this to do item.
It's like your own web-based SQL Server management studio.
Yeah, that's right. And we can get things here. So it's now we created the service, and now we've created a table. So you can look in the table and look at the columns. By default, you always have an ID column, which is indexed, and nothing else at the moment. The interesting thing about this is that this thing called dynamic schema is turned on. So we can just send it requests with columns in it, and it automatically will create columns in the database.
That's
it's
great.
really, very, very cool.
That's very NoSQL-ish.
Yeah. And then all I need to do is to go into the... so that's actually, we've got a basic site there. So I can now go back into my project. Here we go. And in the... find the right place. In app.xaml.cs, need to uncomment that. And in main page.xaml.cs, uncomment that. And then I need to... we're going back into where we declare the client. Oh, I need to add a reference to the, because we're getting a thing there. Just phone extensions. Here we go. Windows Azure Mobile Service Managed Client. I'm going to add a reference to that, and that should get rid of that red squiggly. There we go.
Get rid of the squigglies.
Yeah. And then in here,
Bad.
Bad.
uncomment that. And then we need to add an app URL and an app key. And we go back to the here to the app URL is here, this thing here. So, oh, go to the dashboard for this guy. Here we go. There's the mobile service URL. So I'm going to just copy that, stick that in there instead. Control V, and we need an app key. So you have to manage keys, and you have to go and get the application key. Copy that, and stick that in there, and that configures the client. And then we just got do a couple of changes to the code in this sample application that they give you, which is basically to uncomment these lines here, which is to get the objects defined that we need to interact with our to-do table. And then uncomment this guy as well, and change it to an async. Oh, I need to remove that one. That was the old in-memory version of it. There we go. So that should get rid of that squiggly. The refresh items here, this is what goes off to the Azure service and pulls the items down, so uncomment that. And then this one is to update an item, so we can uncomment that as well. Update that, and we have to make that async because it's making an awaitable call. And we should be good. I think that's pretty much it. So now I can run this, and we can create a new item in here. Finish up, please, because we're over time. Save it, and oh, I spelled it wrong. But then I can go off back to my portal. Yeah, close that. We can go to data, to do item, and it's got one record in it, so we're looking good here. See the one record, and I can't figure out how to open it up. I'll just click on this, and we can browse it. Finish up, please. It's in the cloud.
Please. It's in the cloud.
Yeah.
How did you do that?
It was just awesome. So,
Mobile to the cloud. It's like peanut butter and chocolate.
So, yeah. So,
don't you think? I don't think anything goes better together than mobile and the cloud. So get after it.
The beauty of this is, I mean, and this is just the start. It's got a really good authentication story, so you can get your clients to authenticate against Twitter or Microsoft account or against Facebook, and use those a way of authenticating your clients. Great support for push notifications.
Yes.
So that would be the next thing I would have shown you, but I haven't got time. So you'll hear a lot about this, and catch the build videos. It's really, really cool stuff, and it's multi-platform client support as well.
Absolutely. It's good stuff.
So that should be us pretty much done for this. Let's just take back to the slides. There's Windows Azure Mobile Services, which I showed you. Yeah. So in summary, all that stuff.
All that stuff that he said, and he's done.
Yeah. All right, we're good. I'm not even going to read all that stuff.
All right, and we're good.
We will take a 10-minute break, and then we'll be right back with some Tap to Connect. Great stuff. Bing. All right, see you soon. Thanks.